We're continuing our discussion on the classification of matter. I know this isn't the most exciting thing you've been doing in your life lately, but there are some important concepts here that we need to sort of hammer out before we move on to other things in the course. So far we said matter can be broken down into two broad categories: pure matter, which is only made out of one kind of thing, and we said those were elements and compounds. And I gave you a list of 31 elements that you guys need to know for this class. There's actually 92 that occur naturally, and there's 118 currently elements that either occur naturally or have been synthesized in the laboratory. Well, like I said, you're only responsible for this class for knowing 31 of those, and that would be their symbol and their name. Compounds, on the other hand, we said are substances that are composed of two or more different elements chemically bonded to each other. Not mixed together, but they're actually bonded to each other. Now, on the other side of this chart, we have mixtures. And there are two different kinds of mixtures we need to worry about. The first kind of mixture is called homogeneous. Some people pronounce it homogeneous, which is just fine. The other type of mixture is called heterogeneous. Now, homogeneous mixtures I like to think of as having only one phase. And heterogeneous mixtures I like to think of as having two or more phases. Homogeneous mixtures, we like to say, are uniform mixtures. And heterogeneous mixtures, we like to say, are non-uniform. Let's go to the bottom of this page, and then we're going to define these terms for you. And we're going to give a lot of examples. Hopefully, you can understand the difference between homogeneous and heterogeneous. So if we go down to the bottom here, we have a space for our definition for homogeneous mixtures. So a homogeneous mixture is a uniform mixture of only one phase. So let's try that again. A uniform mixture of only one phase. We often call homogeneous mixtures solutions. So another word for a homogeneous mixture is the word solution. You've probably heard of that before. A solution is made up of a solute or a solvent. A solute in a solution or a homogeneous mixture is the component that gets dissolved. And it's usually present in the lesser amount in the mixture. The solvent does the dissolving. And it's usually present in the greater amount in a solution or in that mixture. Here, let me give you an example. Let's say, and this is sort of silly, I passed around a beaker, and the only thing in that beaker was pure water, H2O. That's an exciting demonstration, isn't it? You've got some water. It's being passed around the room, and you're looking at it as though you've never seen it before. Pure water would be a compound because it's two or more different atoms chemically bonded to each other. So you'd say, okay, Hummer, I get it. That's made out of one kind of thing. There's only water in there. It's a pure substance. It's two or more different atoms bonded to each other. Therefore, it's a compound. All right? The next beaker I'm going to pass around will have some salt in it. So I'll just put a little pile of salt down here. We're going to choose sodium chloride as our salt, NaCl. So there's just a pile of salt in that beaker. Once again, a very exciting demonstration. It's passed around the room as if you'd never seen it before, and you say, wow, that's very interesting, Mr. Hummer, just to humor me. And you'll say, Mr. Hummer, that's a pure substance because it's only made out of one kind of thing. It's made out of this compound, sodium chloride. I know sodium chloride is a compound, Mr. Hummer, because it's two different atoms bonded to each other. All right? Well, the next thing I want to do is I want to take that sodium chloride beaker and I want to pour its contents into the water beaker. So now we have this beaker which has water in it and sodium chloride in it, which you know dissolves in the water. And we stir it up, and you know what? You can't see the solid sodium chloride anymore because it's all gone into solution. And you'll say to yourself, Mr. Hummer, that is now impure. Well, why is it impure? Well, because it's two or more different things mixed together. It's no longer just water. It's no longer just sodium chloride. I now have a mixture. Well, that mixture happens to be homogeneous because when salt dissolves in water, we have only one phase. We have this aqueous liquid phase of water and sodium chloride dissolved in it. It is considered to be a uniform mixture or homogeneous mixture. Do you see the difference now between pure compounds and impure mixtures? They're made out of two or more different things as opposed to being made out of only one kind of thing. Now, some folks think that solutions always have to involve water, but that's not true. For instance, let's say I had a balloon, and in this balloon, I have air in it. Now, air is composed of elemental nitrogen and elemental oxygen, for the most part. It's about 80% nitrogen and 20% oxygen. That is impure. It is a mixture, isn't it? Why is it impure? Well, because I don't have only one thing in the balloon. I have nitrogen and oxygen. It is homogeneous. It is a solution. Because it's uniform throughout. There's only one phase. There's that gas phase. I don't have layers of nitrogen and oxygen in that balloon. It's completely mixed together uniformly. So solutions don't always have to involve water. Here, let me give you another one. Let's say I passed around my wedding band. Now, my wedding band is gold, and if you're able to look inside of my wedding band, etched inside of it is the number 14 with the letter K after it. Now, we think, well, that's a gold band, but it's really not pure gold. It's gold, and there's some silver in there, and there's some copper in there, and there's a few other different elements that are mixed together to make that 14-karat gold. It makes my wedding band harder so it doesn't dent up or bend as easily. So my wedding band is not pure. It is impure again. It is a homogeneous mixture. It's made out of more than one thing homogeneously mixed together. If I were to cut that open and look at it, I wouldn't see layers of gold, silver, and copper and so on. They would be mixed together uniformly. We call that an alloy. And an alloy is simply a homogeneous mixture, usually of metals. Other examples of alloys would be brass. This is an alloy of copper and zinc. Bronze is an alloy of copper and tin. They're homogeneous. They aren't layers of copper and tin. It's uniform throughout. The substance present in the greater amount would be called the solvent, and the substance present in the lesser amount would be called the solute. Okay, homogeneous. It's uniform. One phase. We don't see layers. Okay? All right, let's go to the next page quickly, and we'll define heterogeneous. So, a heterogeneous mixture, as you might have guessed, is a non-uniform mixture. If I could spell here. It's made up of more than one phase. Well, what does that mean? Well, think about this for a minute. What if I had concrete? You know right away that that's not pure. It's lots of different things mixed together. It's heterogeneous. There's more than one phase. If I were to look at concrete, is it uniform throughout, or do I have big rocks and maybe some small rocks and a bunch of sand to fill in the spaces? There might even be air pockets in there, more bigger rocks and really, really tiny sand particles at the top, it's certainly not uniform throughout. There's more than one phase. Think about a hamburger. Well, that's certainly not uniform, and it's certainly not pure. I have thousands of different compounds that make up a chunk of meat. I have fat, I have muscle tissue, there's water, there's probably air pockets in there. It's certainly not uniform, like we saw with air, or brass, or salt water. We have more than one phase. Think of a couple others, like a smoky room. So we have the air in the room and we have the smoke particles in the room. Air is not pure, and those tiny microscopic particles suspended in the air certainly make this a mixture. It's heterogeneous. It's not uniform throughout. Think about it. If there's ever a fire, where are you asked to go so you don't breathe in so much smoke? Yeah, they say to start crawling, because that smoke tends to rise in the room, and there's less of it on the bottom. So we don't have a uniform mixture. It's heterogeneous. I don't know, think of a couple other things. How about pizza? Obviously, it's a mixture. It's not uniform. It's heterogeneous. How about you? You are a heterogeneous mixture. You're not pure. I know your mom and dad tell you you're pure. That's a different way of expressing purity. Here in chemistry, you would not be considered pure. You'd be considered a heterogeneous mixture. So there's, you're more than one phase. You've got some skin, some hair, some muscles, some air, some liquid in your body. You are certainly heterogeneous. All right. In a follow-up video, we're going to do a little worksheet to practice classifying matter into one of the four categories we've learned about, either an element, a compound, a homogeneous mixture, or a heterogeneous mixture. So we'll practice those before you guys take your next assessment.